Okay, so let's move forward to the basic rule of integration. So we have a few basic rule of integration. The first one is the constant rule, where if we have a constant, when we integrate a constant, we simply add x to the constant and then plus with c. So for example, if we have to integrate 3 dx, so this is simply 3x plus with c. So 3 is a constant, simply put x and then we have to plus c at the end. And if let's say I have another constant, pi dx, so this is simply pi x plus c. But be very careful with the variable you are working with. If let's say you have 2 dy, so since the variable is y, this is no longer 2x, but it should be 2y plus with c. So this is also called the constant rule. Okay, so the second one, we have x to the power of n dx. So we simply add 1 to the power, so x n plus 1 over the new power n plus 1 plus with c. But we do have one restriction for the power rule, where the power cannot be equal to -1. So the reason why the n cannot be equal to -1 is because otherwise we have x to the power of n plus 1 over, so we got -1 plus 1 below here. So -1 plus 1 is equal to 0. So anything divided by 0 is actually undefined. So that is why we must avoid having -1 as our power if we want to use the power rule. So we actually have something else for n equal to -1, where we call them the special power rule. So firstly, let us proceed with the basic power rule first. So n is not equal to -1. So we're going to add 1 to the power, divide by the new power, and then plus with c. Okay, so for example, if you have x to the power of 4 dx, so adding 1 to the power, x5 over 5 plus with c. So if let's say you have x to the power of 1 over 2 dx, so we have to add 1 to the power, so it will become x 3 over 2 over the new power 3 over 2 plus with c. Since you divide by a fraction, you can take the reciprocal, so it will become 2 over 3 x 3 over 2 plus with c. Okay, so the third rule is actually similar to the second one, but instead of having x, now I have ax plus b. But be very careful if you want to use this rule. This only apply if we have some linear function only. If you have a quadratic or cubic, you cannot use this formula anymore. So if we have to integrate ax plus b to the power of n dx, so adding 1 to the power n plus 1 over with the new power n plus 1, but we have something in extra over here. We have to divide by the coefficient of x. So the coefficient of x over here is a, so we have to divide by a as well, and then plus with c. So again, we do have some restriction for the power, where we cannot let the power become -1, otherwise we have -1 plus 1, where it will become 0. Okay, so if let's say I have x plus 3 to the power of half dx, okay, so copy down the function. I have x plus 3, adding 1 to the power, so it will become 3 over 2 over, divide by the new power, 3 over 2. The coefficient of x is 1, and then plus with c. But of course, since you divide with some fraction, you can take the reciprocal, so it will become 2 over 3, x plus 3 to the power of 3 over 2, and then plus with c. So move on. So constant multiples rule is when we want to take out the constant. So if you have a constant inside your integral, you can actually bring them out. So for example, if you have to integrate 3x dx, so you can actually bring out the 3 and then integrate x dx. So we have learned this before. We can actually use the power rule for them. So 3 simply copy down, but integrate the x now. So instead of x to the power of 1, it will become x to the power of 2 over with the new power 2, and then of course plus with c. So this one will become 3 over 2 x squared plus c. Okay, so the next one, if you have a plus or minus inside your integral, you can actually separate them into two different integrals. So for example, if you have to integrate x plus 3 dx. Okay, so since we have a plus, we can actually separate them into two. So we can have integrate x dx plus integrate 3 dx. So be careful, you always need to write down your integral as well as the dx. So integral as well as the dx, because both of them are paired. So do keep in mind, these are paired. So you must write both of them. You cannot miss one of them. Okay, so integrating x dx, so this is actually by using the power rule. So x to the power of 2 over with the new power 2 plus, so this is actually a constant. So a constant, we can simply write down x, so 3x plus with c. So you simply need to write down the c once only. Next, so this is the rule if we have some exponential function. So if we have e to the power of ax plus b, so be careful again. If we refer to the power, this is also a linear power as well. So it will become 1 over a, copy down the exponent and then plus with c. So for example, if you have to integrate e to the power of 2x dx, so copy down the exponent e to the power of 2x, but then you should differentiate or take the coefficient of x over here. So the coefficient is 2. So it will become 1 over 2 e to x plus with c. So this is positive. It might look a little bit simple, but if let's say I give you e to the power of 1 minus x. So firstly, if you have some exponential, simply copy down the exponential. But then don't forget, you have to take the coefficient of x. So over here we have -1. As the coefficient of x, so we are supposed to have 1 over -1 and then plus with c. So simplify them a little bit. This is actually negative e 1 minus x plus with c. Okay, so this is the special power rule. So 1 over ax plus b, if you bring them up, it will be ax plus b to the power of -1. So that is why I call them the special power rule, because this is for n equal to -1. Okay, so if we have to integrate 1 over ax plus b, it will become 1 over a ln the modulus of ax plus b plus with c. So the reason why we put a modulus over here is because we want to make sure it is always positive. As you know, the ln should always be greater than 0. So that is why we wrote down the modulus sign, so that we always keep in mind that the number behind the ln should always be a positive number. Okay, so if let's say I give you 1 over x dx, so integrating 1 over x, do remember that if you bring them up, it will be x to the power of -1. So we cannot use the power rule for them. So that is why we have to use the special power rule. So it will become 1 over the coefficient of x. So the coefficient is 1 over 1 ln the modulus of whatever we have below here. So x plus with c, or you can actually simplify them to become ln of x plus with c. If let's say I give you 2 over 1 minus x dx, So firstly, you have some constant here, bring out the constant 2, and then integrate 1 over 1 minus x dx. So 1 over 1 minus x, if you bring them up, the power is -1. So that is why we are using some special power rule. So we copy down the constant. So 1 over, so the coefficient of x over here is -1, ln, so whatever we have below here, so ln of 1 minus x, and then plus with c. Simplify them a little bit, so 1 over -1 is -1 times 2, so this is -2 ln 1 minus x plus with c. Okay, so this is for the exponential, but instead of having e as the base, we are having some positive number here, a. Okay, so a to the power of bx plus d, so I avoid using c because otherwise we might get confused with this constant. So bx plus d dx, so it will become 1 over b ln a to the power of bx plus d plus c. Okay, so if let's say I give you integrate 3 to the power of x plus 2 dx, so simply copy down, it will become 3 to the power of x plus 2, and then 1 over, so take the coefficient of x, so the coefficient is 1, and then ln of the base, ln 3 plus with c. So what do you have is 1 over ln 3, 3 to the power of x plus 2 plus with c. Or you can also write them down as 3x plus 2 over ln 3 plus with c. So this is another basic rule, but this is for trigonometric function. Cos of ax plus b, again be careful over here, this is only belong to a linear function. And if you refer to the power, this is cos to the power of 1. I guess I should remind you for this one as well, the power is a linear as well. So every time we do the basic rule, we always refer to some linear function only. If we have something with a quadratic, we might use some certain technique to solve them. So cos of ax plus b dx, so 1 over coefficient of x, sine of ax plus b plus with c. So if let's say I give you cos of 3 minus x dx, so 1 over, so the coefficient of x is -1, and then sine, take whatever you have, so 3 minus x plus with c. So this is negative sine 3 minus x plus with c. So the last two, also trigonometric function, but with sine and secant square. So if we have a sine, do remember you are going to have negative in front. So sine of ax plus b, again this one is a linear. Sine of ax plus b, so -1 over a, cos of ax plus b plus with c. So if let's say we have sine of 3x plus 4 dx, so this is -1 over, so the coefficient of x is 3, so -1 over 3 cos of 3x plus 4, and then plus with c. So the last one, if we have to integrate secant square ax plus b, again this is linear. It will become 1 over a tangent of ax plus b plus with c. So if let's say we have to integrate secant square of x plus 2 dx, so 1 over, the coefficient of x is 1, and then tangent, take whatever you have behind there, so x plus 2 plus with c. Simplify them a little bit, so this is actually tangent of x plus 2 plus with c. Okay, so done the basic rule of integration.